Hi, I'm Rob Sherwood, CTO at Big Switch Networks. As Kyle was saying, I'm happy to be back for Network Field Day. It's one of my favorite things to do, although we were reminiscing not just about how many Network Field Days we've done, but also the one back in 6 where there's debate about whether I just bricked the switch or caught it on fire. I don't remember if people were in the room. I remember the fan was really hot and the room was really hot, so I actually tweaked the switch to spin down the fan speeds, but then my demo tanked because I overheated the switch. Sometimes software control can be taken the wrong way. So today I'm going to be talking about our big monitoring fabric, how it enables pervasive monitoring, especially security, across an entire network. I'm first going to talk a little bit about the monitoring problem, because frankly, just a lot of people just don't understand it, or they're just not used to it. Generally, people are aware that monitoring is a problem, which is to say most people don't really know what's going on their networks. Right? If I asked you what was the most prevalent application running on your network right now, most people couldn't tell me. And they couldn't tell me what fraction of their network it was taking it up, or how many rogue applications there were. There's just a whole bunch of stuff that just goes on in your network and you don't know. Good news is there are lots and lots of companies that want to sell you some tool that takes packet traffic data to tell you interesting things about your network, whether it's an intrusion detection tool, or something as simple as Wireshark, or something more advanced like FireEye on the security side, or something like Riverbed Steelhead Appliance, which will actually take all sorts of web application performance metrics and tell you about this particular application is slow because it's slow accessing this database server. There's lots and lots of companies that will tell you interesting things about your network. But where do you put these devices? Where do you hook them up? Right, so if you flash back 10 years ago, when most traffic was, say, maybe north-south, it's pretty clear where you hook them up. You hook them up on the egress to your network, and all the interesting traffic leaves, and so there's a clear choke point. So if you want to hook an intrusion detection system up, you put it on the egress part of your network. That's easy. But today, most traffic is east-west. Inside a data center, you can actually have multiple tenants, multiple applications. Stats I've heard is for every byte of ingress egress from the data center, there's 10x those number of bytes inside. Like if you make a web query into your bank saying, tell me what my balance is, the page that generates that generates 10x the number of bytes of internal databases and queries and applications and whatnot. The vast majority of the traffic is now east-west. So in this east-west data center world, where do you hook up your intrusion detection system? Do you buy an intrusion detection system per rack? Nobody can afford that. Forget managing that. Nobody can afford it. And so the question is, what do you do? And the answer, turns out, is we have a product for that. So historically, what's happened is people have deployed what I'm going to call a network packet broker. It is exactly as Kyle was showing. It's a big chassis box where you can take lots of fiber split tap ports or span ports, hook them up to that box, hook your tools up to that box, and just like it's kind of shown here, you can hang some tools off of this, and then you put another network packet broker someplace else in your space, another packet broker there, and because they're a big chassis, you can't have this all is to all function, but for a modestly sized network, this is probably okay. Granted, much like with all the problems with other big chassis, there's expensive boxes that are proprietary. But worse is as you scale out this network, you end up with what we're calling tool silos, which is to say, maybe you've got a span port here which has interesting data on it, but you've got a tool that's only hooked up to a different network packet broker. You can't kind of mix and match arbitrarily. So what we do is using exactly the architecture that Kyle was talking about, this one big switch architecture, and these low-cost white box data center switches, we actually create what we think of as a monitoring fabric. So that is, you can take tens or hundreds of span and tap ports, hook them up to these low-cost bare metal data center switches, manage them centrally from a pair of redundant controllers, and hook up as many tools as you can shake a stick at. And then the idea is, programmatically, you can say, I want the traffic from here to be pulled off to this tool. And then you tell that to the controller, single point of control, and the controller figures out how to make that happen. What does this look like in practice? So this is a real deployment from a real customer, a tier 1 US financial services company, 120 rack deployment. This is a big data center that they deployed. They have racks and racks and racks of switches. They have a pair of production switches at the top of each rack. Those are not our switches. Those are somebody else's switches running somebody else's software. But they have a pair of always-on 40 gig span ports coming out of those switches, which we then aggregate at our first level of big monitoring fabric switches. That first level, just like Kyle's picture, you can think of these as the leaf switches in our monitoring fabric, then goes to a set of spines, to another set of leaves, that goes to a set of ports, a set of tools. And so they run Wireshark, they run Riverbed, they run FireEye. But the cool thing is, with this architecture, you can pull traffic from anywhere in your data center, programmatically at any time to any tool. So the answer to where do you deploy the intrusion detection system, you deploy it in this area down here that we started to call a tool farm. As a new vendor comes to pitch you on, we've got this crazy who's-y what's-it thing that will tell you fantastic things about where to find the rainbows in your network, you drop it in here, and you start using it. As this network scales out, you're not managing this switch by switch. You're not actually managing these switches individually. You're just talking to the centralized controller that then transitively manages out these switches. Does this make sense? This is a bit of a weird, bizarro world. All right. I'm show of hands. Who's ever heard of a network packet broker? Okay. That makes me feel better. So sometimes when I get to this picture, people go, but wait, how do you deliver the traffic, the production traffic? I'm like, no. So we're getting a copy of the traffic. This is not the production traffic. Our job is not to deliver it. In fact, we, for some intents and purposes, actually ignore the headers on there. Because once the packet gets copied out of the span port here, the production network is responsible for delivering it. We're delivering a copy to a tool, totally based on, we're not trying to send this packet to its own destination. We're trying to say, this is the traffic that the operator Bob identified as potentially being problematic, so we're going to forward it off to Wireshark. Like a typical use case here is somebody gets a trouble ticket that says server A can't talk to server B, what's going on? Somebody shows up, tells the controller, send all the traffic between server A and server B, everywhere you see in the network, to my Wireshark instance. Or you can say, I want a copy of all HTTP traffic from a certain range of servers where I happen to have this problematic application deployed, sent off to my Riverbed appliance for performance tuning. Does this model make sense?
Mm-hmm. Mm-hmm.
Yes.
Questions? You guys usually ask more questions. All right.
For this customer, how are they programmatically interfacing with it? Custom homegrown application? Or are they using some portal you have built into the controller?
It depends wildly on the customer. So there's three primary interfaces to our controller. One is a graphical user interface, which we're going to demo in the next session. So you guys will see that. One is a command line interface. So if you have a bent towards a command line interface world, we can meet that need. But both of those actually just speak to our REST API. So they're actually REST API clients. Right. And so there are customers who are talking directly to the REST API. And
like self-service portal internally, app admin needs to see this or something.
Well, and so we actually have a bunch, and I'll talk about it in a little bit of a sec, but we have features like role-based access control. We have features like overlapping policies that actually make it so no customer that I know currently builds their own portal to talk to this.
Got it.
We've got a lot of that functionality built in-house. Cool. I will say we are starting to talk to customers about using this as a service. So imagine you're a service provider. You've bought a bunch of these tools. You're renting out racks or VMs or something like this to end customers, and they're coming to you saying, I'd really like to have some sort of, intrusion detection system that goes through my stuff. And then the service portal actually becomes a self-service portal for the end customer saying, okay, I'm willing to pay an extra $100 a month to send all my traffic through a couple of FireEye boxes. Cool. That's the model we look at. Other questions, or should I move on?
Is there any means, I guess I haven't thought this one all the way through, is there any means to, so if you have a bunch of racks that are supporting multiple customers, is there any means to tag or somehow identify that traffic even based on port in your switch to say, this is customer A versus B? I mean, I'm thinking like overlapping IP space. So like if we had like a big cloud, we could identify at least where, from a customer perspective?
So we have a couple things that we can do. So in addition to forwarding the packets, we have the ability to remark the packets in a couple different ways. So kind of the most general form is we can add a VLAN tag, or if there's already a VLAN tag, we can go to Q and Q.
Okay.
So if you think of it as, you come up with some numbering scheme of this port is this VLAN tag, then it's possible to do that.
Okay. Gotcha.
And in fact, that's particularly useful in a different scenario, which is so imagine if server A is over here and server B is over here. As the packet traverses through the production network, you're going to see multiple copies of it. And it's nice to be able to tag the ingress port, because then you can see, look, it went through this port, it went through this port. It should have gone through this port, I think, but I didn't see it here. Now I think I know where the problem is.
Gotcha.
I have a question for that example. Did you have the same bandwidth than the production network?
So that's actually really what the magic is that makes this architecture possible. So traditional network packet brokers are built off of network processors or FPGAs, which can keep up with line rate. They're really programmable. There's lots of interesting things you could do with them, but they're particularly expensive for their bit rate. We figured out how to do this with the same data center chips that run in the production network. So yes, we absolutely keep up with that same speed, but we can do it at a much cheaper rate than a traditional network packet broker.
So in your model, the monitoring network has the same, let's say, capacity bandwidth than the production network, yeah?
At least the ingress. Now, the rub here is actually the tools themselves, the eventual delivery, these are actually the bottleneck. Normally, like if this is like doing some high-end DPI or something like that, that's not going to be able to keep up. So really, it's like we're using this ASIC-based data center packet forwarding hardware as a really high-speed filter. So we're, typically you can think of it like dropping 99% of the traffic on the ground, but programmatically forwarding the intelligent 1% that you're interested in.
Okay.
It is possible in theory, like so I should say, we have the ability to load balance across a bunch of tools. So if you're willing to buy enough tools to actually consume all of the production network traffic, you could actually monitor every packet in your network. Now, practically speaking, the tools are the more expensive part of the solution. In fact, with this customer, the original design called for 2 complete sets of all tools, one for the left half and one for the right, with some idea of redundancy. In this type of network, we actually do the equivalent of both traffic engineering as well as failure recovery. So if a switch goes down, we can reroute. And so because of that capability, they decided they didn't need a redundant set of tools. And back to the price, the removing the redundant set of tools actually more than paid for the entire solution.
Okay. I've seen problems if you, let's say, double the traffic on 3 different ports, yeah, then you have 3 times the traffic, yeah?
Yeah.
Okay.
And so what's nice about this is it's actually configurable. So we can do full line rate across all of our ports. So the switches in this deployment were 32 by 40 gig. So we can do full line rate of 32 by 40 gig.
Okay.
And you'll see in a couple slides we're about to have a 32 by 100 gig switch.
Can you speak to the filtering mechanism? Excuse me. So you said packets come in, they're getting filtered at the edge. I guess, is that happening in hardware?
It's happening in hardware.
Yeah.
So, digging into maybe more detail than what you wanted, basically what we have done with our switch light software that sits on that switch is we've disabled most of like the L2 learning, the L3 lookups, like all of the standard packet forwarding stuff, and have really abused what is effectively the policy-based routes part of the chip to drop most, like there's a default policy to drop traffic, and then we effectively whitelist traffic in with what looks like a policy-based route.
Okay.
So you can think of the controller as installing a whole bunch of intelligent policy-based routes to almost create a circuit through the network.
Okay.
Layer 3, layer 4, layer 7.
Well, so yes, and yes. Well, not layer 7. So let me come back to what you can match on. But the short story is L1 in terms of the ports that comes in, L2 in terms of source des and MAC ether type, VLAN, lots of L3 features, stateless L4, but we actually can't do cross-session things. And then the interesting feature, the DPM feature, will let us do an offset match, and I'll talk more about that in a second. So this is one big use case for us. A completely different use case is actually in the mobile operator environment. Exact same tool, completely different deployment type. So you've got lots and lots of mobile phones here. You've got a radio access network. You've got an ingress router. But then you have the S and P gateway. And if you know nothing about mobile, don't worry about this. These are like weird mobile operator terms. But these are the things that actually do the magic to enable mobile service. And so people have installed taps before, during, and after to understand what's going on. And so the tools that they use are things that do things like billing assurance. There's some high-end voice over IP quality assurance tools that will tell you if there's too much jitter in your voice traffic and things like that. They use lawful intercept. They have a whole bunch of tools they won't even tell us about. This is actually deployed in a number of large nationwide carriers. We're big in Japan, if I can make a pun on that. We've got a bunch of carriers in the US, a bunch of carriers in other other big countries in Asia. This is a really big use case for us because these people have all sorts of kind of government mandated requirements that they can't hit in another way. But does it make sense how it's basically the same software in a different deployment? A third interesting use case is around reduction of the number of tools. So imagine you've got a data center much like I showed in that first picture, but then you have a whole bunch of remote data centers that are maybe smaller. And again, because the tools are kind of expensive, or maybe a remote data center might be physically remote, hard to get to, if you drop one of our switches in, we can actually tunnel selective traffic back to the main center. So the idea is, you've got a packet here that's of interest. You tell the controller this is of interest. We will actually encapsulate this in an L2 GRE tunnel, push it over a wide internet link that gets decapped here, and then forwarded on to the relevant tool. So you can think of this like some sort of, it's not the actual technology, but you can think of it a little bit like pseudo-wire or something like that. But does this make sense why it might be useful to folks?
Yeah.
Mm-hmm. All right. Two things, the nice things that customers have said about us. One, Intuit has been public about its use of us. If you filed your taxes through them in 2014, your traffic got monitored by our stuff. Monitoring is a critical feature for them. A company I can't mention, but it's Fortune 50, so you can think of them as big. They were deploying us in multiple data centers worldwide, and they had an outstanding problem that was lasting for months. There's a lot of finger pointing involved. And they rushed the deployment of big monitoring fabrics. They thought correctly it could solve the problem. Within 5 minutes of being deployed, they verifiably could say, this is what's wrong. And so it's a nice tool to have. That ends the overview of what this is, the problem case. I'll start again to go into some of the deeper of how this works. So I'll just introduce myself again. So hi, I'm Rob Sherwood, CTO at Big Switch Networks, and now I'm going to talk a little bit about a deeper dive into the architecture for Big Monitoring Fabric. So same rough picture as last time, a little bit more detail. You have your production network. You have lots and lots of span and tap ports, potentially hundreds, depending on the size of your data center. You have a collection of our bare metal switches managed by a pair of centralized controllers, and you have a bunch of tools. So on the controller side, it is a pair of redundant controllers. If one goes down, the other takes over. No data loss there. It has a whole bunch of built-in telemetry and analytics and whatnot that we do in addition, so we're not just a dumb plumber. We actually take up some of the data as well. Most of the demo is going to be spent talking about this. We deploy on other people's switches. We're a 100% software company. But it turns out with things like Open Compute, with things like the Dell Open Networking, it's actually possible to get switches that have no operating system on it. And so we deploy our own operating system on that. Last, and this is what's interesting and new, we are now starting to ship something that is philosophically the same as a services node that you would actually do, like a service blade that you'd put on a router. But we implement it with a standard PC using DPDK. And if you aren't familiar with that, I'll talk about that as well. So this service node, the idea is It turns out that x86s can actually process packets pretty quickly if you program things the right way. Now, programming the right things the right way turns out to be very hard, which is why Intel pushes a development kit called DPDK, the Data Path Developers Kit. It's a whole bunch of pre-set up libraries for pushing packets around really quickly. In terms of how really quickly, at least on the current boxes we're looking at, we can do full line rate across 4 10G NICs. We can actually do much better than that. It just involves some additional boxes. So imagine you've got a 1RU server. It's got 4 10 gig NICs on it. And then we can dump that traffic that's been filtered through the network through this box and do additional kind of higher end features. What do we do? So currently, we've implemented packet deduplication, packet slicing, and a regex style match. So packet deduplication is, remember the use case I was talking about, if you see a packet traverse the network, you can get multiple copies? In some cases, that's a good idea. In some cases, it'll confuse the bejesus out of the tool. And so if you get a tool that's confused by that, and we'll show in the demo, you click a button saying, for this particular policy, make sure it gets deduplicated. What that means is it will actually intentionally loop through one of these boxes. So that circuit that we put together, instead of going directly to the tool, will actually service chain, if you're familiar with that term, through one of these boxes, and we can support many of them in the network. And then it keeps track of packets that have gone by, it removes duplicates, and it's totally transparent to the end service. Ditto with packet slicing. So packet slicing is taking a full packet, chopping out the payload, and sending only the headers onto the tool. Some tools only care about the headers. If you think about it, chopping out the payload, you can actually increase the bandwidth of the tool pretty quickly. And there's even some privacy uses for that. So particularly with large telcos, some countries have significant privacy laws, and so forwarding on the payload of the traffic gets a little bit scary for people, and this ends up being nice for that. Regular expression matching, that's also pretty nice. Like that's a pretty advanced feature. But the critical thing is we can do that at full line rate for 40 gigs of traffic per node. If you need more than 40 gigs, you deploy another server. The nice thing is this falls exactly into our larger view of it's all centrally managed. You don't have to log into the server to set up something different. You log into that same controller. We'll show you in the demo. You check a different box, and you get one of these services. What I get excited by is these are the things that actually fit the feature completeness list that make it, when people compare us against other network packet brokers, these are the things that people are like, well, you can't do these things with Broadcom ASICs. It's like, okay, sure, you can't. But now we have the services node, so we're pretty much feature complete at this point.
So when you say add another server to get more, if you're deduping, for example, is there any communication between multiple servers so that you don't end up, well, I've deduped half of the stuff here, but the other half went through the other server, and then ultimately they're going to still be duplicated when they get there? Or do you effectively have to kind of waterfall?
So what ends up happening, this is an important thing I probably should have described. When we load balance across multiple tools, we use the same kind of flow sticky load balancing that ECMP might use. So all of the packets for the same flow go to the same server. So we don't have to do that hard problem what you're getting at.
Okay, and you can do that even if they're not connected to the same switch. They can be anywhere on the fabric.
Exactly.
And you can still spray.
Yep.
Okay, very cool. Thank you.
Other questions? Am I going through this too fast? What I get excited by is this is now a platform for us to deploy new services. Maybe we start doing SSL decryption. Maybe we start doing timestamping. Maybe we start doing all sorts of things. This becomes much like once you have a services blade in a router, this becomes a thing for us to deploy. This is how I'm going to spend my next year, thinking of new and fun, crazy things to do off of this box.
Once you've got a server in with the switches,
Yeah.
you can really do some software stuff.
Well, and I like to think of this as you've got the probably typically a Broadcom ASIC doing the heavy kind of dumb lifting, which is it's deciding based off of packet header features which packets to forward. It's not doing much. Maybe it's adding a VLAN tag, and then you've got kind of the somewhat slower but much more programmable x86. And between the two of those, you can actually do some pretty interesting things. Either one on its own, yeah, there's something there, but the combination of the two, particularly where the user doesn't have to worry about it. right? You're still talking to the controller. The controller actually manages, okay, well, what's being handled by what box? Does this make sense? This is kind of a core principle.
What is this running OS-wise, and is it zero-touch provisioning in terms of plug and play, back to the controller and whatnot? Or?
Yes, Linux plus DPDK is the short answer. I mean, so we sell this as an appliance. So if there's ever, I mean, it's from a security perspective, it's completely stripped down. But if there was ever an issue or an update, we would issue an update for that.
And can you elaborate on the regular expression stuff? What are you matching on, just out of curiosity?
So the fun example is things like matching the agent name in a web request.
Oh, okay.
So we have a demo where we do something like that.
Yeah. Are you going to talk about like how you do that at line rate, or can you?
No.
That's fine.
Yeah. I mean, there's IP there.
Sure. Sure.
But as you're getting at, that is a hard problem.
Yeah.
And, most of these things, there's actually some pretty advanced algorithms in terms of how you get those done at line rate, particularly in a DPDK environment where you're really trying to keep up with the packet rate.
For sure. Yeah.
Other questions on this? I think this is something that's pretty interesting. So I mentioned briefly that we have role-based access control. So what does this mean? So if you think of the monitoring network as a service, like you might have lots of different people in your organization, depending on the size of it, that need monitoring. So you might have a security team, you might have an operations team that's trying to figure out why the network is or isn't working. You may have application teams that are narrowed in on their own applications. And there's no need to have monitoring networks for each of these teams, although practically that's what a lot of customers are doing right now. So the idea is you actually have one common use, big monitoring fabric deployment, and then you can give different teams different roles. And those roles can be limited by what tools they can use, what ports they can filter on, which protocols in those ports. So, maybe the security team can see everything. Maybe the application team can only see the couple racks where their applications are running. Maybe the operations team can only see ICMP traffic. These are all policies that can be set up and managed. The thing that falls out of here that gets to be an interesting problem is what do you do when you have overlapping policies? What do you do with the packets that the security team wants to see that the operations team also wants to see? And so, maybe one team is filtering on this packet, another team is filtering on this packet, no problem, there's no overlap. What do you do with the overlap? And so the answer is we build up the equivalent of what looks like a multicast tree in the operation and in the monitoring network. So we actually, at full hardware line rate, will actually duplicate packets in an optimized multicast tree, making sure that transparently both teams get the packets that they're looking for. Does this make sense? I mean, it's almost like this weird, bizarro world, the monitoring network, because we do traffic engineering to figure out when we place the circuit, where do we place it? We do failure recovery. We'll do the equivalent of multicast here. But none of this is production traffic. All of this is mirrored monitoring traffic.
This feature relies on on the service node, right?
No. So the mirroring at line rate is actually a feature we can get out of the Broadcom chips.
Oh, cool. Okay.
And actually, it reuses the same multicast bits that get used in normal multicast.
Gotcha.
Make sense? Do I need to start issuing mandatory cookies?
Caffeine.
Completely different use case, back to Jason's question about how people are using the APIs. So one thing that's cool is because we have an API, everything that you can do with our controller is API manageable. You can actually create policies dynamically on an event. So imagine you've got an intrusion detection system running. Some evil bad packet, we'll call that red, shows up. And it goes, wait a minute, this is weird. I'm not ready to wake up the operator because it might be 3 in the morning. Let me make a dynamic call into the controller such that when those packets show up again, I want them also copied to Wireshark, or I also want them copied to a permanent packet capture device, so that when the operator wakes up in the morning, he can have a full packet capture of what went wrong, what the IDS thought was weird, rather than getting a page at 2 in the morning. The people are starting to do some pretty interesting things. We've done some, at least some demoware level integration with Blue Coat on this. Particularly in the mobile operator space, there's some interesting stuff that can be done here.
And how do you identify intruder traffic? You bring some basic rules, or?
So that's really the intrusion detection systems problem. So from a Snort context, and if you actually, we've got some demos that show this, but Snort has a whole bunch of rules for like this is what's weird. But then it has a programmable scriptable language you can say, on finding something weird, what do you want me to do? So it's a simple drop-in of a Python script. So when Snort decides that something's weird because of one of these rules, call into the controller to record it, or call into.
Okay.
Yeah.
And so it's a Python script that does a REST call.
Oh, Python are your choice. Python's mine.
Right,
But
yeah.
yeah, exactly.
Okay.
Yeah.
And so this has got a lot of security people thinking some interesting thoughts here.
Yeah.
I mentioned 100 gig. We have 100 gig switches working with our software on them right now. So they're going to deploy in a 32 by 100 gig format. They are non-blocking at full line rate at 3.2 terabits of total throughput. This is game changing, particularly the prices that are associated with these. These switches are just about to hit the market. Our software is already running on them. The rough consensus is relative to traditional network packet brokers. Port for port, these will be an order of magnitude cheaper. And so, as the world starts to move to 100 gig, this starts to get very interesting. I should also say, with both of the boxes that we're going to support, you can take these 32 ports of 100 gig, you can break them out into 6440 gigs with the breakout cable, or you can use this special breakout cable and get to 4 ports of 10 gig. What is that? Notice 4. So 4 ports of 10 gig each as well. So it's a lot of 10 gig ports. Make sense? People are asking, what else can you match? So I mentioned all the L2, so L1, all the L2 features, L3, lots of different features, source, destination IP, IP toss, those types of things. In addition to that, we have this offset match feature that we call the deep packet match. So the idea is you can have a fixed offset from either the IP or the layer 4 header saying, offset this number of bytes, match this field, and that is the inner IP address destination inside your VXLAN. Or that is the TDID, your tunnel endpoint identifier in a mobile stream. Or that is the third inner MPLS tag. This is kind of an area for operators to really get interesting. And so we have support for a whole bunch of protocols on this. At the same time, we expose the generic offset match functionality. So as people want to use it for different things, that gets interesting as well.
And that's matching anywhere in the packet?
It is up to 128 bytes in, and then it's a 4-byte match. So offset by 128 bytes and match 4 bytes with a mask. So yeah, the big uses for this are GTP tunneling, MPLS, and getting inside of pesky things like VXLAN.
Are you headed towards rewrites? So some platforms that work in this space will see an MPLS tag and strip it out, or see a VLAN tag and strip it out, so you can translate.
So
There's no point in handing the MPLS tag or the VLAN tag up to the IDS.
with VLAN tag, yes, we're doing that right now. With MPLS tag, I think you may have just written one of my new services on the service node. So basically, MPLS strip. So that, to your point, most tools don't really understand MPLS.
Yeah. You pass an MPLS tag to Snort and it just...
Yeah. Well, and because I know this is a real problem, I can almost guarantee that what people are doing is using high-end routers to strip that tag. And that's a expensive port.
Yeah, well, you can program it into the silicon if you've got enough time and energy.
Yeah.
But
Q&Q was another one that used to kill, because you get software that would understand HTTP1Q, but could not deal with Q&Q.
That's actually an interesting use case. I'll have to write that down or record it live.
I'll send you an invoice.
All right.
Yeah.
If you need a reminder, you can go watch it on the web later.
We can offset it for the cost of the water. A little feature, but one that ends up being really useful. So our controllers deploy as an appliance. It's a physical piece of hardware. You have 2 of them. That appliance newly has a 10 gig port on it, like separate from the control channel. So you can actually do lightweight packet capture directly to the controller. So from the graphical user view, we actually have the web version of Wireshark built into it. You can say, what's going on here, rather than spin it off to some Wireshark somewhere else, just like click, click, click. Oh, that's what's going on. And so, I mean, this is not groundbreaking. It's not going to replace proper packet capture tools, but this is pretty useful.
Troubleshooting. That's a troubleshooting class capture. Yeah. I've got a web server. It's not working. Put a capture in. Do a PCAP. It's only getting half the sessions or something here.
And a quick snapshot of all of the interesting features that we have put into this. So we actually have interesting visibility across the entire network when you deploy this at scale. We've added the ability to track all of the hosts and figure out what their locations are and map how often we see them. You can get that from the controller. We've done the same thing for subnets, the same for DHCP and DNS. What DHCP and DNS servers are being used in your network? Oh, that client's using some weird DHCP server that is not supposed to exist. Let me figure that out. We've also figured out how to generate and collect S-flow. I'm not going to get into any of these features because we were talking about it in the demo. But more and more, we're moving away from being a dumb plumber to somebody who's actually aggregating information and pushing it up to the consumer. Any questions on this, I'm happy to answer, but at the same time, you're getting in the way of the demo where people are going to show it to you. So.
Okay.